and hello again. So yeah, second part of the stream today. Yeah, now we need to figure out what to do with the nav meshes and what's going on there. So let me see, where do we start? We managed to build a nav mesh with the C++ version. Although it looks like it was a little bit off. I'm not sure what was wrong there. But yeah, it was a little bit weird. But yeah, we managed to test the movement flags and basically prevent monsters from getting out of the water, which is perfect. But yeah, we still need to figure out how we're gonna basically generate the nav meshes. Would it be the C++ or C# tool? And how do we store settings basically between multiple instances of the tool. So let's try to figure that out. So first of all, I really wanted to try and basically rebuild that that recast project. Let's see if we can do that with a rider. Probably not, because that's actually a .NET 8 project. But maybe. Yeah, .NET 8 is not fully supported. So what if we where was the MS build settings? Maybe I need to ditch rider toolset here. Okay, .NET 8, don't use ReSharper build. Would that help anyhow? In any way? So it looks like it is running a .NET 8 to build, but yeah, Rider doesn't like that anymore. So I guess screw Rider. We can use Visual Studio, or we can use Visual Studio Code. Actually, this one's oh, okay. Well, it's building, but yeah, looks like Rider doesn't like that at all. Can I... Where was the clear invalidate caches? This is for all projects now. Huh. Well, I guess I'm changing IDEs now. So can we just open that with the Visual Studio? It's not up to date, by the way. Probably I should update Visual Studio first. But let's see what it's gonna say. Can it handle the project? It looks like it's not .NET 6. I do have .NET 8 SDK installed, but yeah, I guess I need to update the Visual Studio. And 1, 2, 3 to you as well, Creata. How are you doing? So let's try to update Visual Studio. In the meantime, we're gonna figure out something else. So let's close that. Let's also close this. Now it works. You mean the iOS application? So what do we have here? Yeah, I have C++ build insights. This is a weird installer. I remember a different Visual Studio installer, like where you could select modules and stuff like that. Maybe it's change update settings? No. Well, no, it's checking updates again. But okay, let's try and update our Visual Studio. So I was thinking how we're gonna deal with that nav mesh generation. And I came to conclusion that I really like the C# implementation of the demo tool. And besides that, I'm pretty sure that we would need to like add some custom modifications to our system. Because yeah, demo tool is just built for demo purposes. It has like demo areas and stuff like that. Probably we will have our custom area types and stuff like that. So my idea was we just fork the demo project. We still use the C# libraries, but we use them from Nugget packages. But we basically recreate our own navmesh build tool. And that way we can also try and make the scaling work properly. So maybe we could use nav meshes that I scaled. Why the music annoys me? So probably we can make it build nav meshes in the same scaling as we have in the client and in the server. So basically in old Unreal units, which would be great. Then we would basically save some CPU cycles on the server side, which is nice. So I think I'm just gonna fork the demo project, name it like navmesh builder or something like that, make it use the Nugget packages for everything else. And yeah, basically go from that. And then we can teach that navmesh builder, our custom fork, we can teach it to load the volumes that we export from the game and we import into the server. We can also add some kind of offset to water volumes, which would be nice. So I think I'm gonna do that. Yeah, it's a little bit extra work, but we already settled on the nav meshes that this C# tool generates. I like it. And yeah, it's behaving better than C++ version. It's more responsive on big models, which is surprising. Still, that surprises me that C# version is faster than the C++. But yeah, I guess that's just probably the C++ demo project is not very optimized. But yeah, first we need to actually make it work. But wait. Yeah, so one problem is if we do this fork and we start from there and we implement all our custom stuff, then we basically would abandon any improvements that developers of the .recast project would do to this demo project. Because I think, like, I took a quick look at the implementation. And it doesn't look like we can extend this demo project at all. Like, it's pretty much hard-coded. If we would like to modify it somehow or alter the way it works, we would have to basically rewrite it. So one way would be to create an actual fork and basically backport any changes that appear later. But that would mean that we keep all the other subprojects and stuff like that. Maybe that's a good idea, actually. I don't know. Yeah, like it's updated 2 months ago. Added UI scaling feature based on monitor resolution. So yeah, this is nice. Okay, if we just fork the project and we do some slight modifications to the recast demo, but we try to make sure that we keep our custom stuff like separated from the code so it's easier to merge, then we could probably update it without too many problems. I don't know. Is it worth it? Or we can just copy it. We can replace the project imports with nugget imports and do whatever we want. It's just it's going to be harder to backport any changes. Also, if we just create a new one, then probably we can use .NET 6 without any problems. Continue using our rider. I don't know. Or we can forget about it and use the C++ version, but then I think the C++ version is a little bit different. Maybe it has some kind of offsets. That reminds me, I wanted to test Prontera map. So let's do that. Let's create... Let's create a nav mesh for Prontera. Right. Oh, I guess the focus of the window gets in. But okay, let's try to basically recreate the nav mesh for Prantera. And see what is the difference. Okay. So at least that was fast. So now we save it. For some reason it's a bit smaller than the one generated by the C# version. That's weird, but okay. So Prantera, this one, enable. Save. I forgot to enable the test spawns and have test2 spawns. So let's restart. Okay, where is the NPC? That was not really promising, but okay. It doesn't work. Why? It loads the nav mesh. Well, let's enable the normalization again. See if that fixes it. I don't think so. Well, at least it managed to normalize it. But it doesn't want to build the I know why. Because we excluded the walking movement in the filters. Where is it? Here. So, yeah, that makes sense. Okay. Do we have enough set here? No, this looks good actually. This looks exactly the same as it was before. That one's going. Where is the 𝙽𝙴𝚁𝙑 employee? That looks good. So what's wrong with the bridge? That looks perfect. That looks exactly the same as it was before. Hmm. This one is stuck. Why? Why are you stuck? You were working perfectly. Let's check again. Can we now open the .recast project? Why are you standing here? Weird, but okay. Maybe there is a waypoint that I forgot about. .NET 7. I'm gonna ask for every runtime separately. What's going on with him? I think he was not supposed to stand. I think this is the client server synchronization problem. And the NPC is actually working properly. Let me see. Yeah, the NPC is actually pretty far away. So I don't know what happened there. Okay, so what do we have here? This is still installing. So what was wrong with that bridge? That was weird. Wait, not that one. Warp 2. Oh, you know what? I didn't install actually .NET 7. I did install .NET 8 SDK. And I had the .NET 6 installed previously. So maybe we can now open the project in Rider. Let's see if Visual Studio can compile it. Build, rebuild solution. So let's go and see that bridge again. So, let's spawn a monster right here. And make it aggro. Get stuck. That was weird, really weird. As if we have some kind of offset here. Okay, where can we test this theory that we have an offset? I need some kind of... Oh, maybe here actually. Here it goes perfectly around the obstacle. Looks like here as well. So what's wrong with the bridge? Oh my god. So this is horizontal basically. Let's check this fence. Do we have an offset here? Doesn't look like it. It looks perfectly normal. So what's wrong with the bridge? Like for real. Oh, it gets stuck here. Gets slowed down here on this ledge. And then it gets desynchronized. Okay, let's try the other way around. Okay, make it unstuck. Let's try to spawn it here. And attack from below. Wait. That was unfortunate. Yeah, can't make the... Oh, okay. We could... It fell through. Oh my god. Base of the bridge have a plank. Yeah. Yeah, this plank. Even I get stuck here. Okay, what if we spawn it? Oh, okay. We have a monster here, so let's make it go around. Yeah. So nothing is wrong with the nav mesh itself, although I would like it to like avoid this plank. But technically, yeah, this plank should be walkable. It's just the client-side glitch, unfortunately. Our parameters are correct. The client should have just jump on top of it, right? Like right here. Let me see, actually. Okay, so basically at our knees is the height that the character can jump. This is lower than that. And yeah, you don't even jump, it's just... it throws you back. So this is definitely a client-side glitch, so nothing's wrong with the nav mesh. Okay. Play with elevation settings. No, I don't need that. This should be fixed on the client side, 100%. Like, I need to fix this bridge anyway, because, yeah, the monster did fall through the planks. Like somewhere, I don't know where, probably there. It managed to fall through. We need to basically change the collision mesh for this model. We need to create a custom collision mesh that's much simpler, that's not built of planks, but it's just one plane here, some walls for these for the railing. Yeah, it was a small crack. And it fell through because I actually changed the way the collisions work on the client side, because I wanted to optimize it a little bit so the monsters have easier time avoiding obstacles. So now on the client side, the actual physics collision of every monster is 10 times lower than its real collision that's being used by the gameplay calculations. Yeah, now the radius is of all the mobs are very, very small to make them avoid the obstacles easier. So, yeah, that. So, okay, so the C++ program actually generates proper nav meshes. There is nothing wrong with that. One thing that I wanted to check. Oh, so yeah, we managed to build the project with the Visual Studio. What I wanted to check, I lost my thought. What was I talking about? Oh, I wanted to check how we detect which kind of file do we load, 32-bit or 64-bit. Where was that? I think that was in core. Let me see. Nav mesh params. Mesh set reader. No. What do we use here? One sec. Nav mesh test. Here we use DT mesh set reader. So how do we detect if we need to use 32-bit? We don't. So you have to specify that. So the C++ version of the library produces the 32-bit binary file. We have to use it. So maybe we can add a flag to this table, like 32-bit. Yes or no. And we load based on that, but okay. So I also wanted to check if I can use Rider still to open the .recast project. Because probably we were missing the .NET 7 SDK. Maybe that was the only problem. At least I hope so. Synchronizing projects. It's running the analysis. Maybe we are good. Come on, why is it so slow? So, we can still use the C++ version. By the way, did I build it with, release? No, this is a different project. Where is the real project? Here. Okay, so yeah, just the .NET 7 was missing. I think that was the only problem. So we can use radar technically. Okay. So what are the options? We can use the C++ version to generate all the nav meshes. It's not a big deal. It's just, yeah, it's a little bit more work. So basically the work pipeline would look like if we introduce a new map or we modify a map, we would have to first of all export the data from Unreal Engine to STL file, open it in Blender, scale it, export it from Blender to obj file, put the obj file in the meshes folder of the recast navigation demo, open it in the demo. No, not open it yet. So we would have the gset file. We would need to also export all the physics volumes from the game, then convert them from vertices to the convex volumes that recast expects, put them into the gset file. Then we can open the gset file in the demo tool. Maybe adjust something, like fix some models, build a nav mesh. It will preset the settings, it will preload all the volumes and stuff like that. Build the mesh. The mesh would appear as a binary file that's not named properly. So it would be called, where is it? Wait, what? Where does it save it? It was saving it in the working directory. Now I don't see it anymore. Oh, this is a different library. No. No, that's the one. Where is Prantera then? There is Prantera. Can I save a gset? Yeah, I can. So where is the navmesh file? Oh. It was not detecting the click on the button because the FPS is so low. Okay. But yeah, it basically saves the file as all tiles navmesh.bin in the working directory of the program. So we would have to rename it to something more comprehensive, then put it into the navmeshes directory. And then we're done. If we would build our custom C# tool, we could make it load. We would still have to export the geometry from the engine, convert it with Blender to obj file. Maybe we can actually build in the converter into that tool later on, but okay. We can even skip the scaling part, which is gonna be a huge plus, I think. Then instead of the gset file, we just import the volumes directly. We can build an importer. It should be very small and very easy to do. Then we can build the nav mesh, and it saves with proper file name. But actually it still saves in the project directory, but we can change that. We can save nav meshes. We can like build a file saving dialog and save nav meshes where we need to, because we would have full control over that. But I don't think it's worth it. It's worth the actual hassle. So I think we're gonna use the C++ tool. Like, yeah, having this functionality in the C# tool would be a little bit more convenient, but still, I think this is good enough. Just I would have to write some README, some small guide on how to actually generate the nav meshes, how to work with them. Okay, but then we need some kind of conversion tool from the volumes that we export from the game to the volumes in the gset. And I'm not sure how to do that. What would be the best approach? Like, it's not hard. It's relatively easy to convert to this format, but what would it be? Like, small console utility or some kind of script? Because I don't want to do that manually. It's too much work. And yeah, it's very tempting right now to just use the C++ tool and build all the meshes for all the maps, but that's actually this conversion of volumes from one format to another. That would take a lot of time, so I need to build this tool to use the C++ version. Or we can basically create the importer into this C# version. Forget about the gset, although the gset functionality should be relatively easy to do. Basically, this is where was it? Here, load jump set. So basically, we need to implement two methods, one for save, one for load. And yeah, basically handle the files, and we can actually implement the proper file path relative to the gset file. Connections, volumes, settings. So it shouldn't be hard to actually implement that. Let's build that into the demo tool. So release, I've managed to build this project, right? Now let's run it. Gonna exit the game, by the way. And yeah, we could adjust the UI to our liking. That's another plus. So this one, the biggest map and the most complex one. I like this UI better than this C++ version. And I can input the values directly. I cannot do that in the C++ implementation. Nope. So yeah, I like this better. And it's performing a little bit better, I think. Well, now maybe not. Now that I've built the 64-bit version, it actually behaves normally, I think. Okay, so let's not waste any more time. Let's try to implement the volume importer from the game files. It should be pretty easy to do. So we need to find this load source geom. Button. Also, well, okay, it can stay open. So what is this? RC settings view. Okay. Properties, input mesh, separator. Okay. Then just button. So okay, that's like text, separator, button, text. Okay. So this is simple enough. Okay, so let's add a new line here. Well, not a new line actually. We need a separator. Wait, not here, not here, not here. This is... Okay, rasterization, separate. Aha, I see, I see. Well, let's just add another button. Why do we have the same file playing? Okay. So we need another pop-up with the file picker. Geom load begin event. Okay. Let's close this. Wait, not here. Here. Okay, so this is gonna be... Can we actually do .vol.csv. Not sure if it's gonna recognize this kind of extension, but hopefully. And now, what's going on here? Yeah, looks like we need to ditch rider anyway. But okay. We need a new event. So let me see where this is. Let's just copy. So rect2 volume import begin. Hello? Hello? Yeah, rider doesn't feel very well. Wow. Wow. Really? Okay. File path. Now let's see where this event is being used. We need to add another handler here. So this is gonna be on rider. What are you doing, buddy? Basically, it's like a text editor at this point. What are you doing? Okay. So I have that. So we need to go back and update this. Good. Now here, we will do actually something similar to this thing. Oh my god. Here we need to actually load the file. Let's do it like here. And instead of load nav mesh, we're gonna create, where is this load nav mesh, by the way? Oh yeah, this is stupid. We don't need the file path here, but okay. Yeah, we basically now need to parse a CSV file. It's just gonna be fun. But okay, file stream. What is this crap? But okay. Let me see, how do we, yeah, CSV reader. Do I import this CSV reader? I think I want to. Yeah, looks like this is a newer version. Okay, we passed the culture info here. Yes, header record, okay. File path is this one. My god, Ryder, are you... Screw this. Okay, so recast demo. Okay, good. At least now I have indentation. That's already a good sign. So we open the CSV file. Now we need to parse it. So volume type. So here we will have one for water and stuff like that. Let me uncomment this piece of code. Yeah, right now we only care about the water, but okay, the type is going to be useful later. We need not actually polygons, but we need something similar. We're not gonna load the planes, we're gonna load vertices. Let me open the file. So this one, for example. So vertnum. Now, yeah, let's read all the vertices. So this is going to be, by the way, I think here it's better to convert them directly to the recast units. RC vector 3. Now we're gonna read all of them. Exactly like that. With the conversion, which is gonna be slightly different. But okay, read float, which looks like this. So it's vert, then a number. Instead of times 100, times 1000, we're gonna do times 100. Right? Yeah, right. Times 100. Or divide by 100. Wait. Divide by 100. Right? Let me take a look at this one that I was working with. Yeah, so we divide by 100. Then we need to basically find the highest one and the lowest one. This is not the normal, this is vert. Wait, vector 3. This thing, not vector 3. Okay, so we have that. Now we need to find the highest and the lowest values. So here we have, I think, two ways of filtering out the vertices. So we have 8 vertices, 4 on the top plane, 4 on the bottom plane. In most of the cases, they will match in terms of x and y coordinates. They should match. And the only difference is going to be the z coordinate. But this is not guaranteed, actually. So, what we could do is detect the highest and the lowest point, and load only the highest vertices. Or, wait, can we load some of them? 36, 16, 16, 36. 16, 36, 16, 30. No, this doesn't make sense. Oh, another add a head. Okay, show me. What head do you want? Can you give me a link to a rate my server or something like that? So I think the more reliable way would be to work with the z coordinate and basically detect highest and lowest one, because we still need those two values. So we read all the vertices, right? Now what we can is verts order by Well, rider was a little bit more convenient on this part. But okay, order by. Oh, and we need to swap the x and y. So from here, we do it like that. So we put the x into the x. We put z into y. We put y into z. Right, and now our y is gonna be our height. So order by that. Then to list. Then we're gonna do var min height. It's gonna be ordered by height first. Right? First y. Actually, no, it's okay. Max height, last y. Okay, so now we have this portion. Wait, so here for now is gonna be, oh, this is nice. If type not equals 1, we continue. So we only load the water volumes. Oh, I see. This is nice. Okay. And by the way, you can request not just the heads, but other facial accessories. So like glasses, I don't know, mustache or something like that. So not only head top, but also head middle and head bottom, or full face accessory. So yeah, basically anything that you can see in the original Ragnarok Online 1 game on the head of the characters, you can request. And you can even request animated heads as well. But those are gonna be expensive. So, okay. Now we need to filter out everything that's not near the max height, right? So, how do we do that? I can use link again. Vy minus, wait, we need to add some small error correction just in case there is some kind of rounding discrepancy. So we need Vy minus max height. This should be an absolute value. if this is less than 0.01. So this is gonna be our final vertices. Okay. Now we need to actually add this as a volume. So where is this thing created? So convex volume sample tool. Actually, we could add this function to this tool, right? Where is this thing? So if we select this convex volumes, we could probably add this button somewhere, I don't know, here. Import convex volumes. But okay, for now it's fine. Maybe we can add it later. Okay, so we have that. So how do we add a volume? This is render. Wait, what? Handle click, tool try add. Convex volume tool. Ah, this is from the tool set. Nice. Actually nice. So try add. So we need this geometry, right? We can get it from the sample. Sure. So actually, do we have a geom property? No. Okay, we have the geometry. Then we add convex volume, create convex volume, then add it. Okay, let's copy this. We need to figure out how we create this thing. Aha, I see. So we have this. No? Ah, float. Ah. Wait, how? Ah. Okay. I see. Okay. So let's do not verts. Let's rename this to polys. How do we rename in Visual Studio? Not polys, but points. How do we rename in Visual Studio? Like rename refactoring. Okay, there's probably a hotkey for that. It's just I'm not very used to. I renamed it to polys. I need this to be points. And this is supposed to be point num. Okay, oh, and I forgot to actually add this point to the array of points. Okay, cool. Can actually combine that. Some suggestions in Visual Studio are pretty intelligent. Think I should try to get used to it. I don't know, but I wanted to try Visual Studio Code. Okay. So now here, this is actually top points. Now we need to convert these top points to vertices like that. Oh. Wait, what? This is actually not it. I'll point. Oh, no. It's okay. It's okay. So we need. We need this. Okay, so we have the verts. Now hmin is. Actually, I can rename that. And this is hmax. Area type is gonna be this type for now. What's wrong? Oh, area modification. I've seen it somewhere. Final references. Here. So sample area modifications. Water. Area mod water. Yeah. So, okay. This tool, so it created a volume. Try add. Created edit. That's it. That's it. We don't need to call like re-render or something like that. So maybe this is it. Maybe we can just try and run it. It's in debug, but okay. So what can we test real quick? What would be the best one? The easiest one? Let's try this one. Oh, wait, this is Prantera. No. And this is debug. No. I already forgot how to use Visual Studio. Hold F01, this one. Import volumes. Client game data. Not editor, geodata volumes. Okay. So here's the first problem. We cannot filter out the extensions like we tried there. So we need, where is it? Another head, okay. I'm interested now. What kind of head did you pick this time? Where is this thing? One sec. It's RC settings view. Where is it? In UI. Makes sense. Okay, so now we need just CSV files. I think that's the problem. So let's see. Geodata volumes. Here we have the volumes. Out F01, this one. There is an exception. Header has not been read. The hell? Ah, CSV helper. The header has not been read. You must call read header before any fields can be retrieved by a name. I see. So it looks like that's something new. Let's see the documentation. Huh. Read header. And then we do the read in a while loop. Okay, sure. That's new. But yeah, that was expected because I actually upgraded to the new major version. But actually now this is easier, to be honest. So let's copy that. So reader equals this thing, then CSV with invariant culture, read header, then while read we use CSV. Yes. Let's try that. Here we go. We just created a water volume. Okay, so now if we build this nav mesh, don't care about the settings at the moment. Let's enable the tiling. Let's build. Okay, looks good. Looks like we have ourselves a water nav mesh, although it looks weird. I think it looked different a little bit. Let me see. So if we close this, not crowd control, but convex volumes. Well, this is grass for some reason. Yeah, it looks a little bit different. Huh. I don't think I've exported this correctly. Imported, I mean. Because this looks differently. Like, looks like there is no top portion of it. Did I mix up the hmin and hmax? It looks like it's like inverted or something. Weird, really weird. Area type. Ah, okay. Have area type. Oh, I can do this calculation. Just in case. What is this hull? Points, hull. Box descent, box height. Min age. So this actually calculates the minimum and maximum value. But it's fine, our calculation is also okay. Probably offset. I don't know. And then see what could be wrong here. Maybe it's just like too big or something. It looks correct. Okay, what if we actually build it for the big map? It still looks the same. That's weird. Is the y coordinate important in this case? But okay, what if we build and in the meantime we can maybe do this. Actually, let's try with, I don't know. Let's actually try h max minus h min divided by 2 plus h min. So it's gonna be halfway through. Looks correct. But yeah, it's weird that it's not showing the water surface. It did show the water surface on the test model. Don't see any errors. But okay, what if we test the nav mesh, we exclude swim, wait, I don't see any path. Huh. Weird, it doesn't show the path. Maybe it's just too far away. Ah, I see. So this is probably what was happening there. On the beach. Basically, I was too far away and it couldn't build a path. So instead of that, the server just made the NPC go in a straight point. Okay, that's good to know. I'm not sure how we can avoid that. Okay, crowd control. Create agents. Give me one. Move agent. Oh, we cannot set the filters for the agents, I don't think. Oops. Move agent. Okay, this is a little bit weird. My main question is why why don't we have the water surface? Again, maybe it's just a little bit too big to render. Let me try. Well, first of all, I changed this. And now let's try Prontera. Oops, not game data. Load volumes. I didn't export Prontera volumes in the new format. Let me do that first. Okay, let me take a look. Volumes F01. Okay, 8 vertices, good. Can close that. Now we can open this file. Okay. Let's take a look. Where is the water? There it is. Yeah, for some reason, it's like inverted. I can see the points in the middle. At least that's good. But why is it like inverted? I don't see the top one. Strange. Yeah, like I see the surface here. Maybe I'm supposed to swap the hmin and hmax. I thought hmin is like the actual minimum value, hmax is the maximum. Maybe you're supposed to swap that. Let's take a look. No. It's still doing the same thing. Now it's even more broken. What the hell? Wait. Maybe it is like that. This is height. This is how deep it goes, right? Yes, I need that. Still looks like it's flipped. I don't know. I mean, my imported volumes look like they are flipped compared to these ones. This is weird. Hmm. We don't have a logger here? No, we don't. Hmm. What am I doing wrong? Why is it inverted all of a sudden? Yeah, the minimum should be minimum. But what's going on there? I'm not sure. Why don't we see the surface? Why it looks like the polygon is flipped? Okay, so let's inspect this volume. Twelve vertices. Oh, 12 divided by 3. Okay. I don't know. Okay, I have an idea. Maybe that's just because our model is a little bit too big. Let's try and load 1 second. Let's try to load Printera again. And let's create manually a bigger volume. Convex volumes, water. And let's create it, I don't know where. 1, I don't know, 2, 3. Now it looks fine. So what's going on? Why does it render it differently? What the hell? If we go into the building, we still see this mesh displayed properly, this water volume being displayed properly. I have no idea. Why is it upside down basically? Or at least rendered upside down? Do we need to somehow reorder the vertices? I don't think that matters. Really weird. Still invisible from this point of view. Still flipped. Why? Okay, let me try this. If we do, maybe this actually matters, the y coordinate of the vertices. Maybe they're supposed to face h max. So if it's h min vertices, we can assign them to h max. So they face up. This is the only place where I can see it can be different. No. Still upside down. Okay, what if we do the other way around and we use H max here and H min here? Or maybe we're supposed to... Wait, how do we assign these points? No, these are supposed to be points on the map. I don't know. This is really weird. I don't know what to do about it. Same thing. Okay. How do we render those? Yeah, this is what I was afraid of. It renders it in a different way. So they have to be organized in proper way. Okay, let's see. What if we include all the points? They're gonna be duplicates, but we're not gonna order them. Well, instead of using the top points, we're gonna use just the points array as it appears. And just iterate over every point. Right, we read it from the array. We still use ordered by height to determine hmin and hmax. That's okay. And yeah, we're basically gonna include all of them, including the top and bottom ones, as they appear from the game itself. Okay. Still nothing. And now it's even more weird. No. The same kind of weird. Okay. Just for giggles, what if we invert this, reverse it? Yeah. Now we can see it. So what's the deal with that? But okay, this looks better. Hopefully this is consistent across all the maps, but I'm not sure. But yeah, looks like it's just the way it's rendered. It just builds the polygons that way. But okay, can we alter this behavior somehow? So this is the triangles that it's drawing. Basically, I think it's just drawing them inverted and they're not double-sided. Debug draw. Depth mask. Vertex, vertex, vertex. Vector end. OpenGL draw. Okay. Vertex. But okay. That's fine. That's fine. Draw elements. I was hoping to find there somewhere like double-sided or whatever. But I'm not gonna dig into that. At least I found why it's not working. So now, what we're gonna do is we're gonna use points where they are maxed to this. What's going on here? Capturing variable h max that hasn't been captured before requires. Okay, we can get rid of these logs. Okay. Let's see if that helped. And let's try on the 𝙽𝙴𝚁𝙵. Okay, that's much better. So this is rendered correctly, this one as well. And this side, let's check the other side. Yeah, that's good. And this one should be transparent from the bottom. Yeah. Yeah, we are good. And it shouldn't matter at all for the nav meshes that we build. It's just the way we render it. Which is still useful, but okay. So what are we gonna do now? I guess we build enough meshes using that. So we've built an import Ragnarok 2 volumes tool into this demo. I want now to build the release version. Can I select the .NET version now? Okay, whatever. But yeah, this looks good. Good enough. Now. Yeah, it's built with .NET 8. Nice. Now we can try and finally build a proper nav mesh for outside of 𝙽𝙴𝚁𝙵. res maps .f02. Also, I wanted to increase the shift travel speed. I mean, the travel speed of the camera with shift all held in, but that's fine for now. So, import volumes. F02. Okay, looks good. I didn't add any offset, so probably that's a good idea to also add some kind of offset for this. But for now, it should be fine like that. So we set the settings 0.15, 0.1, 0.6, 0.6, 53, Thailand, 512. Build. So now we would be able to use this nav mesh on the server. In the meantime, we need to change the way we load the nav mesh. Where is it again? Here. Okay. This is still building. Okay, so besides that, we have default filters. Okay. we have the normalization. Okay. And yeah, we also need to build the Prontera map, because that one is currently being used. The old one, the C++ version one. So probably let's just start a new copy. And let's build this one with volumes now. Let's check how that's being rendered. Okay, good, good. Now let's set the settings again. Yeah, I need to do something about these settings. I can just preset the settings that I have, but maybe I would actually implement the gset format for the C# implementation. No, we'll see. Okay, point 15, point 1, point 6, point 653, 512, build. Okay, here we already have the nav mesh. Okay, actually looks good, and we have the surface, the water. Let's save nav mesh. Yeah, I like that it saves with the proper nav mesh file name based on the geometry file name. So now we go to nav meshes. Wait, where is this nav mesh again? Where did it save? Oh, here, in the project folder, okay. So this is our new 𝙽𝙴𝚁𝙸𝚂 nav mesh with water. And we're building, and this is our Prontera nav mesh. Again, with water. Right? Yeah. Save. Put it there. Yeah, also I would like to save the dialog to appear when I click save, so I can specify where I want it. But okay, it's this one, right? 1925, yeah, that's my time. Now we put it here. We also export the data. Okay, so now all our monsters right now can travel however they want, including swimming. We can actually do a very quick fix for that. So we can do something like if movement types, I need another parenthesis, movement types and movement type swim. Yeah, I need to sort this out. I need to change the way these movement types are implemented. But yeah, swim, I guess. Let me actually double check. There's supposed to be this thing. Okay. So yeah, swim or dive. Oh, swim and dive. Okay, so let's copy this condition. So if the movement type swim and dive, then we actually we do include flags. What was the idea? Oh, here it is. 2. So this indicates. Oh, I see. Well, then it would be easier if we do exclude flags. So we need to invert this if. So if movement type doesn't contain swim, doesn't contain dive, then we cannot swim, right? Now, what about the fishes? I need to take a look how we actually load them. NPC prototype table. Where is the movement type? Move type. Okay. Now, okay, let's build the include flags. We're gonna do it in a way. So if it can swim or dive, we add the swimming include flag. Now, if it can walk, then we do walk. I need to double check the actual. Here, walk is 1. Ground grass road. 2. Swim in the water. Doors, jump. We don't care about anything else. So if it can walk, we add walk. If it can swim or dive, we add the swim. Then we assign the filters like that. Again, walk, dive. Stationary seabed creatures, though. Still fine. Now swim or dive. Walk, crawl, walk on ground and underwater but cannot float. Walk and dive. Yeah, this is a little bit more complex than we have, but it's okay. For now, anyway, we don't care about the fly. Walk, swim. So majority of the monsters should have 6 movement type, right? Where is the move type? Where is the move type? Here, 5. Majority? No, that's not majority. This is 1. So majority has... The normal NPCs can only walk. Okay. This is good. So they don't go into the water. Now monsters. Can 1 or 2, this doesn't matter. Then Aster has 5. And Vadan has AD 5, which is walk crawl. So they can walk and dive, but cannot swim. Walk and dive, okay. We have 4 for mermaid. This is swim and dive, they cannot walk. Perfect. 3 for marine sphere, this is stationary, they can only dive. Okay, 4. This is fish. Swim and dive. Okay. Yeah, so this looks fine. So just these 2 our conditions should cover everything. And these are gonna be our only include flags. Did I save this? I think so. Just in case, I'm gonna export the data once again. And yeah, we're gonna just use nav meshes for Prontera, for 𝙽𝙴𝚁𝙸𝚂, outside 𝙽𝙴𝚁𝙸🻻, and Prontera. And we're gonna... Are we gonna load everyone? No. We're not. We're not gonna do that. Let's just load the test. So now we can restart the server and log into the game and see what's going on. No, I'm not gonna close this yet. I can close this though. So let's test. Okay. So looks like we have our nav mesh. It looks more or less fine. For some reason the offset is a little bit more than usual. But it's okay. Now, we need to spawn someone like 𝙽𝙴𝚁𝙸𝚂. Oops. I didn't mean to spawn, I needed to test a nav mesh. Okay. So right now he's on the nav mesh. And he managed to go into the water. Because we failed to build the path actually. So he actually follows me straight, but his position gets normalized, so he is on the ground. Huh. What if we try to go from here? Now he shouldn't be able to reach me. Yeah, he stays out of the water. So we need to handle this case when we can't build a path. It shouldn't fall back to like the straight following through the air. But okay, now let's spawn. Who else do we spawn? Aster, for example. And we're gonna spawn it under the water. So let's see, what is the nav mesh, what is the path? Okay. So Aster should be able to swim and walk. So yeah, it's following the path. It's following me here. It avoids the obstacles. Goes around the rock. Now it failed. No? Wait, what? Oh. It lost the aggro, so now it goes back into the water. Let's watch it. And in the meantime, we need to find an actual fish. Well, mermaid will do, I guess, as fish. Okay, let's look for this movement. So Aster should go down into the water. Yes, it goes down. Okay, now let's spawn a mermaid. Okay, so there is a path from here to me. How the hell did she get out of the water? I think this is just the failed path building, yeah. Path building failed, so it fell back to the straight way. How do I fix this? Yeah, I think I understand. So basically, if we supply only include flags that include swimming only, basically that means that the whole nav mesh gets filtered, so it doesn't include the swimming at all. Doesn't include walking nav meshes at all, only swimming. And that means that I'm no longer considered on the nav mesh. Okay, okay. Can we use different filters for different entities? No. No, we can't. But okay, if we have that, so I would probably need to, yeah, to disable the fallback to the straight path. And to do that, I need this update path. Okay. So we can just get rid of this, and it should fix it, I guess. So we clear the path. If this succeeds, then we append all the nodes to the queue. And if queue is still empty, then we just add the destination. But now this actually means that we failed to build a path, right? So yeah, if path count is 0, then we have a failure. Okay, well, probably we can set it like create a separate config option for this. But okay, let's see if that actually fixes this problem. Okay. And yeah, now she's stuck there because she cannot follow me. No, don't tell me you managed to follow me. No? No, everything's good. Yeah, now the path is not being built, so she's actually stuck in the water. Well, not actually in the water. So we need to implement the offset for the water volumes when we build the nav meshes. How are you debugging the game, if you don't mind me asking? Yeah, no problem. Legally stupid. Well, there is multiple ways, and again, depends on what I need to debug. If that's... here I have MMORPG, so I have a client and a server. If I need to debug a server, then yeah, this is just a normal C# application, and I can technically put a breakpoint somewhere here, attached to a running process. It takes a while to list all the processes. And yeah, we have a breakpoint. So now every time we build a path, we can just debug. We have the source code for it. Well, yeah, I've created the server side for this project from scratch by myself. So yeah, I can debug any of that. If I need to debug a client, that's a little bit more complex, but still, it's very similar. I can still use debugger. But yeah, sometimes it's a little bit more complex than that. So for example, if we have... Oops, I need to get rid of all of this. So for example, it's very common that I need to keep the server running in real time while still like debugging and outputting some information. So for example, I cannot make it stop on the breakpoint, and I need it to continue running and see what's happening. Then I'm just adding some console log outputs. But yeah, it's a pretty normal debugging process. So this actually fixes our problem. So I'm actually gonna create a separate configuration option here, which is gonna be... How do we name this? So this is basically... This option will make it fall back to following straight path through the air when we fail to build a path. It should be something like fail on like an available path or broken path. No. Fail on failed path, that sounds bad. Fail on empty path. Fail on no path. Just gonna be true by default. Now, where is our update path? So if this fail on update path, if we don't fail on update path and the path count is 0, then we just add a destination as our final and the only path node. Okay. Okay, this looks good. Let's check out Prontera. And let's take a look at this NPC. Why don't we have... because this is a limited spawn configuration for the server. Okay, this looks good. Let's check out the other side. Okay, this looks good. Now let's check out your movements. It was a little bit hard to tell if that's correct. That's definitely different to the C++ version, by the way. But I think I may have used different settings on the C++ version when I generated the Prontera map. But yeah, this looks fine. She actually goes where it needs to. But yeah, now we have a body of water here. And we can go down there. So let's test the nav mesh for ourselves. So, okay. Yeah, there is some kind of like skip volume that prevents me from actually interacting with the actual model. I need to get rid of that. We don't need that anymore. But yeah, this looks fine so far. So what if I execute it in the middle of the water? Yeah, it tries to pull me down. How do we normalize the position? Wait, it's not here. It's here. I think I just... Yeah, I need to include this into this thing. So let's check now. This means that I would have to basically get rid of any other geometry normalization that I had. I have to disable physics volume normalization. I have to disable terrain-based normalization, and just let the nav meshes do all the job. Okay, I'm curious now, what's gonna be the actual normalization for me. Actually, I can do it here. Yeah, it tries to pull me down still. Yeah, it tries to pull me down to the bottom. Wait, what are my movement types actually? I don't think I checked that for the characters. Wait, I have a bunch of monsters as well. Wait. So what are we doing here? We find the nearest poly. And that's gonna be the bottom polygon. Closest point on poly. So yeah, this will always pull me down to the ground. And yeah, I should have the swim movement type anyways, because otherwise this polygon would not be available at all. So this is tricky. This is tricky. I don't think this library can let me do whatever I need. So, for example, where was it? Find random point. Guess the height of the polygon at the provided position using this height detail. What is this for? Okay. Find nearest query polygons and tile. Find path. Sliced path. Append vertex. Okay. Append portals. Find straight path. This is the string pulling. Move along surface. Still haven't figured out what this is for. This method is optimized for small delta movement and a small number of polygons. If used for too great a distance, the result set will form an incomplete path. Okay, that explains why I didn't render it properly in the demo tool. Result path will be equal to the... So how is it different to straight path or something? Oh. This method treats the end position in the same manner as the raycast method as a 2D point. See the method documentation for details. If the visited array is too small to hold it, okay. Portal point, this is protected methods. Raycast. This method is meant to be used for quick short distance checks. If the path arrays, again, is in the hit parameter. If the hit parameter is very high value, then the array has hit the end position. No, I don't need the array cast. Find police around circle. Find police around shape. Find local neighborhood. For small search radius and small number of result polygons. Okay, weird. Get polywall segments. This documentation, I can't find distance to wall. Is valid polyref. Detection of mesh. Get path from the extra search. Get path to node. Close list. Yeah, I don't think we can do that. So what I'm trying to do is, if I'm on the ground, so near the actual mesh, it should just find the nearest position on the nav mesh. But if I'm in the water and I can swim, then it should keep my z current. So probably I need to restore my my physics volume logic that was doing that. Basically what it was doing is, after we normalize the path, normalize the point, it restores the original z coordinate if I'm in the water and I can swim. Let's restore it and see what happens. I don't remember why I had to disable it, but there was some kind of problem. Oh, we actually have that. Or did I just uncomment it? I don't remember. But yeah, we have the volumes, right? And we have this logic working. I see. So yeah, it's supposed to be working right now, but I was querying the nav mesh geodata provider directly. So this is why it was displaying the z coordinate that actually is pulled to the ground. But I should be good. So regions, water. So that means that it was working all along. Let's restart the server and test the mermaid once again, just to be sure that it's actually working fine. Because that's a little bit weird that it works. I remember having some trouble with that. But maybe that was trouble with the terrain. And yeah, now we don't need the terrain at all, which is great. So, we have the regions, we have this fix for the swimming entities, right? Now, the geodata provider will have normalization enabled. Okay. I need to restart this. This is too laggy. Okay, so we should be good. We have the filters on the normalization. Let's restart the server. Make sure that we have everything set correctly. Also, let's enable all the spawns. Should I do that? Yeah, let's enable everything. And let's see how it's working. And also I'm gonna enable all the nav meshes. Just I need to be aware that for big monsters we still use old nav meshes without water in 𝙽𝙴𝚁𝙸𝚂 and in Prontera. Well, everywhere basically. So we have that. Now we need to export. And restore the server. So we can close this. But yeah, we still have one problem that we need to solve, which is the monsters that can... Wait. The monsters that can swim but can dive, so basically like crabs and stuff like that. They should crawl on the bottom of the sea. It's not gonna happen at the moment. They will probably float. Also, all of these are probably not aligned with the nav mesh because they are too high. Yeah. They are too high right now to snap into the nav mesh. So that's another problem. Not sure how we're gonna solve that. Previously the terrain helped us with that, because terrain works in a different way. So if the nav mesh fails to normalize the point, the terrain will actually make it snap how far high it would be, however high. English, please. So basically they will fall to the terrain. Right now it's not happening. Right now this Aster is floating. But okay, let's test fishes first. Let's spawn a mermaid. And see how that works. All these fishes actually floating correctly. So if I hit this one, it should start running away. I think it tries to snap to the floor, unfortunately. Maybe not. Maybe it was just the furthest direction from me. It's not snapping right now. Huh. If I go up... I don't know. This looks weird. Let's spawn a mermaid. I need oxygen. This looks okay, I think. She tries to keep distance away from me. And she follows me if I go too far away. But she tries to go away if I get too close to her. Okay, let's lure it into the water. Out of the water, I mean. Yeah, it doesn't go out of the water. This is great. But yeah, now I can see that right here the pathfinding fails and she no longer follows me. But if I get closer a little bit to the water mesh that she can swim on, then she tries to follow me. So this is a little bit weird. I'm not sure how to fix that. I can increase the extent. Come back. Can increase the extents of each agent, so it actually snaps to the closest polygon. But okay, this is good. Now at least she can't go out of the water. And if I spawn a 𝙽𝙴𝚁𝙸👂, yeah, it can go into the water. It stops there. Okay. So this looks good. I'm still not sure if the normalization works correctly. So far it looks okay, but I remember having some problems. Let's try... Who else can we try? Tuna. And let's try making it follow me to the surface. Oh, yeah, there is a problem. She went straight to the bottom. And now it goes up and down, up and down. Oh. Oh, no. I think I know what's going on. So yeah, this works, and it follows me properly in full 3D space. But as soon as I get out of the water, it can't find the path to me, and it glitches to the bottom of the sea. And as soon as I dive... Well, this is weird. Close the aggro. What is this? That was weird. Can't explain that. What's going on? Wait, what? Yeah, it can't build a path from there to me. Why? And also, yeah, when I get out of the water, it fails to build a path as well. So if I'm right about here, and I select any other fish. No, this looks good. It actually goes to my position, right? Minus 124. So this looks fine, but why didn't it work the... I don't know. Probably it's something to do with the normalization again. So why did I disable normalization? Crap, I don't remember anything. So let's try and disable it again. See what's happening. See what happens. Let's also disable all the spawns. Probably because I get out of the water, it normalized my position down to the ground. So even though the fish could follow me properly, it was looking at my normalized position, which is down before. It turned it on for C++ nav mesh because they require to be normalized. I don't remember. But okay, let's see without normalization. I think I know what's happening. So if I'm on the surface of the water, it actually counts that I'm not in the water, technically. I'm outside of the volume. I'm right on top of it. So when I run the normalization, it doesn't restore my z coordinate, so it gets snapped to the ground. So this is why the fish was trying to go down when I went outside of the water. So let's try that again. Let's spawn a tuna. But it doesn't explain why it gets stuck down there. So let's try to debug this. Yeah, it actually follows me to the surface now correctly. If I go down, it goes down as well. So it actually follows me correctly. Let's try to pull it outside of the water. Well, we already tested that. Yeah, it stops. If I go too far away, it fails to find the path altogether. I get a little bit closer, then yeah, it follows. This is because I'm... basically this path doesn't consider the walkable nav meshes, it only considers the swimming nav meshes. But okay. Let me now fly for a little bit. Okay. It follows me even if I'm way outside of the water, which is good. Yeah, it can't reach me. Okay. Now let's try to reproduce those bugs. Again, I think that was because of the normalization, but I now have no idea how to avoid that. Probably we need to just get rid of the normalization at all. Don't think we need it. What is that? What is that? What is that? It's bugged again. Here. So there is some kind of spot here. Uh-huh. Ah, I see. So this is too deep for me to snap to the nav mesh. Well, now it can't snap even for that one. What? Oh, we don't have the normalization. What am I doing? So it always fails. Then what the hell is going on? Okay, let me test it again. Let's go here. So it's somewhere here that it starts bugging out. Right? Yeah, right here. Yeah, I think this is because I'm too far away from the nav mesh. Guess it's too deep. But why does it go there? Yeah, it basically went to those coordinates. So for some reason, when I'm located up here, and the monster is whatever it is, it fails to build the path, but it builds the path of one point to some random spot on the nav mesh. That's weird. But okay. Anyway, it can't build the path, right? It can't build the path. This is probably because... Let's debug this method. Probably because it can't find the end position polygon. So, start position, end position. Now, start position, start ref. Here we have the reference. We have the end reference. 8842, 8856. So even when I'm this high, it did find the nearest polygon for myself. Well, now the path is different actually. Well, wait, this doesn't mean that it's different. Is that the same position? Yes. So why is it doing that? So my position is minus 28. Let's go down a little bit into the water. Now it works. I see. So yeah, this is when I'm outside of the water, but it was still doing that when I was like here. Here, what's going on here? My position minus 637. So why is it going down there? What? Okay, so did find the start ref. It did find the end ref. Did build a path. Start pause minus 214 minus 220, right? Succeeded with building the path, so straight path consists of... By the way, I need to take a look at these flags. 214. Wait. Start pause. Oh, I'm looking at a run axis. So minus 16 start, minus 7 end. So this is my minus 7, right? Now this is minus 16. Why? Hello, Black Beverage. How are you doing? Good to see you. So this is weird. Ref's 0. Now when it goes back, have 2 points. I have no idea. Why is it doing this? Not 10,000. Let's spawn another tuna here. And it goes down there. What the actual hell? It can even go back where it was spawned. Like right now it's trying to go back, but it can't. So start position -16, this is where it is right now. And position -2 is near to the surface. It's found the end ref and the start ref. It's found the path. Right, where is it? Here. -16. Why? Okay, I have an idea. So if we go to some deeper waters, it's not very deep actually. Well, probably this is the deepest point. Let's try the same trick. So we spawn tuna. Why is it stuck? No path available at all. Interesting. I have no idea, to be honest. I think this is because we are too far from the nav mesh So somehow it gets stuck. But why and how do we avoid that? Yeah, they're just stuck. I think this is because they are too... there's the nav mesh is too deep below. Huh. Here it works. So yeah, that's the reason, but how do I fix it? Huh, this is interesting. Find straight path. Well, again, let's reload. I want to debug one more thing. They need all of these monsters to be gone. Well, I could have just despawned them manually, but... Okay, I already restarted the server. Wait, what did I want to test? So now if we debug the pathfinding, so didn't find the start ref. Huh. Okay. Didn't find the end ref. What if I go a little bit into the water? It didn't find the start ref. Didn't find the end ref. Huh. Okay. Didn't find the start ref. Did find the end ref. Failed. I'm not sure how we can fix this. Maybe we can just increase the extent, like a lot. Let's see what will happen if we do that. So where are those defined again? In the nav mesh. Gonna comment this out. And hard code, I don't know, 10, 10, and 100, whatever. So it's gonna be 100 meters above or below and 10 meters around. That would probably help with snapping the monster that are floating too high above the ground back to the ground. But let's see, we need to debug this a little bit. Let's spawn out rested tuna. So now, yeah, looks like now it follows us. This is bad. Basically, recast doesn't consider the whole body of water as a water volume or something. Okay, let's go check out the deeper waters. It looks like this is how we need to do this, unfortunately. But I would need to check if now like multi-level zones are working correctly. First, let's go somewhere here. Spawn another tuna. Like here. Try to make it follow us. Yes. So it needs to snap to the closest polygon. What is this? It's bugged again. Like what? Okay, distance is 22 meters. It's not 100 meters even. I don't know. Can it go back? It can't. So what's going on here? How do we fix this? What if we make it, I don't know, 1000, whatever. Because that definitely improved the situation, but it still gets stuck in a very weird way. Maybe I'm using this find nearest poly improperly. I don't know. Half extents. Maybe I'm not supposed to use it to calculate the path within water or something like that. Yeah, looks like that's the problem. Oh, it got stuck again. So what the hell? So, wait, it's not building the path anymore. Still following the previous path, looks like. Now it goes up. What the hell? Like here, what's going on here? So, start ref, we have that. End ref, we have that. We have a path of 8 segments. Okay, weird. Minus 36. Should be minus 17. I don't know what's going on and how to fix this. Raycast limit. I don't know. Let's take a look. Maybe we can find something in the documentation. So this is find path. So let's open, no, detour. Mm. Nav mesh query. Find path. So find the path from the start polygon to the end polygon. The reference ID to the start polygon. Reference ID of the end polygon. Position within the start polygon. Position within the end polygon. Polygon filter. Do we supply the filter? Yes, we do. Path. This is the out parameter. Number of polygons returned in the path, the maximum number of polygons. Have also some options that are not present in the original library. This is weird, I don't know. Wait, what was I trying to do? Oh, I remember, okay. So if I load navmesh from client, game data, geodata navmeshes, F02, the latest one. Yes. So yeah, the nav mesh looks like this. So it doesn't have the upper boundaries of the water, right? It only have the nav meshes. Here we go. So these are, I assume, the binary tree filters, not filters, but basically boundaries of each nav mesh polygon. Yeah, here we have a gap. Okay. That one is not in the metadata. So I don't understand really how that works. Go from there to here. We do straight path. Area. Huh. What? Oh, there we don't have the nav mesh over this. Ah. Wait. So how do we fix this? We don't have a nav mesh over these pieces of rock. Oof. What about that shipwreck? Oops. Huh. I think I'm I'm started to understand, but still it's really weird, and I'm not sure what to do about this. So the fish got stuck on this piece. Yeah, even though we are in the water. Oh crap. Yeah, it's not that intelligent. I understand now. So, okay, the nav meshes that are marked as water, it's just the normal nav meshes with just additional flag, area flag. And that only gets like affected in the filter, or maybe when we like assign different weights, different costs for each type of area, it will also like consider different different paths to avoid areas with high cost. It's still a normal nav mesh. It's not treating it as a body of water where everyone who can swim can move freely. Crap. Crap, 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 crap. I don't know what to do about this. In my head, the water volume that we defined should have been treated as like a completely free to move area. But yeah, that's not the case. That's not the case. we do need to create some custom logic. Oh my god. This is bad. This is bad. So that means that with my settings that I thought that are good, if we place a point here and there, yeah, it goes straight. So it's not because of the water, it's because of the area flag. It should be like that. Oof. Oof. Big oof. That explains everything, basically. So we can use the convex volumes with some area flags just to define what the polygons generated within those volumes are gonna be treated like. And also it basically splits the nav meshes on the edges, which is good, which is good. But we're still responsible to build a path within water if we don't want the entity to travel like on the nav mesh itself. Wow. Wow. I'm not sure how we can do that. Well, actually, I think I know how to do that. So what we can do, we still use this library to build the path. We use the all flag, so it just follows the nav mesh directly. And it's gonna work for ground properly. It will build proper nav, proper paths. But for the water, so let's say we have 2 points in water, start and end. It will build a path on the bottom, right? But we will have to then adjust the z-coordinate of each point as if it would travel straight. As long as each point is within water. And the NPC can swim in water. Okay, here we go. That's an idea. Okay, so then if we have a path from here to there, for example, from water to the ground. Oh, another thing is, we don't have to adjust it as it would be straight. We can only increase the height. But then we would have problems with vertical obstacles. Oof. Okay, so for example, if we have start in water and on the ground, or this is actually the other way around, and the entity cannot swim, so here, so we will build the path within the water. So first we receive the path from the nav mesh as normal path, basically along the nav mesh. Yeah. Then we try to normalize it, so we basically try to pull it straight, if it can, across the water. Then it stops here. Okay. If we do have the flag to move, then we do that for every point that's only within the water. Only then we like smooth out the z coordinate, right? Oops. Where would be the best? Well, this nav mesh is just weird. Let me see. Maybe I can start here and here. Still, this is a weird nav mesh. But okay. Maybe a good example still. So right now we are using the area crossings that makes it actually go straight within water. Wait, whoops. This is a weird nav mesh. Let's go somewhere with like deeper grooves. Level 7. Area, all. Okay. You know what? I need to build the... Wait. I wanted to see if we have an obstacle. No, this is actually a big obstacle. I need a hill on the path. So from here and then out to here. Does it go straight? It goes straight through the hill. Well, still we don't have that. This is weird. This is a weird hill, a weird polygon. What would be the better example? But still, this actually, I think, works now. Yes, it does work. So what I'm trying to do is, if we have some kind of obstacle that we need to avoid vertically, it should like include the points on each side. Actually, let's see here. Oops. No, it builds a straight path. Yeah, as long as it sees that that endpoint, it doesn't go over the humps. This is bad. So we would have to probably figure that out ourselves. Okay. Well, this makes sense. It's just I expected more from this library. But yeah, looks like it's not possible just with this library. So we're gonna have to incorporate our own solutions on top of what this library can do. I don't think I have any good example of like high obstacle that can be traveled. Oh, wait. Maybe one of these rocks have slopes on the both sides. Or just this hill. Or just this hill. If we start here and there, and we do area, yeah, it's built in a straight line, unfortunately. Trying to see that line. Oh god, frames. Yeah, that's the line. It goes under the hill. If I just do the area crossings, I need the all crossings always. And I would need to manually alter the path that is within the water. Probably I need a good test map that has vertical obstacles. I actually have it. So let's try to load it. So it's this one. Here we have a nice example. Let's load the nav mesh that we already have for this map. F04. This one. And it was somewhere, yeah, there. So here we have a rock that's floating like a bridge. And we have a crossing below. Still, this is not a very good example. But maybe it will do. No, this is not a good example. So if we build a path from here to, there, build the path along the nav mesh, right? If we try to do straight path, yeah, it's not a very good example. And it hits this corner. Oops. Yeah, I think I would need to build an example myself. Or maybe this thing will suit our needs. Basically, I want an underneath passage that goes down and then up. And some obstacle on top. So from here to there, does it cross this rock? Does it go through the rock? No. Actually, yes. So yeah, this is the problem that I'm afraid of, and I'm not sure that I can solve it. So here we build the path. It's going nicely along the nav mesh, but if we define this region as water and we'll try to like smoothen the z coordinate, then it will basically go straight through the rock like this. So this is a problem that I have no idea how to fix. And like we can like if this would be a curved path, we would still have some kind of curved line, but if we still try to interpolate the z coordinate from one point to another, it's still gonna hit the rock, because this rock is not present anywhere on the nav mesh. So can we show the nav mesh alone? Here. This is what sees the server. The rock is not there. It's not present in the nav mesh in any way. And the areas like water volumes that we supply to this nav mesh builder, it only marks the nav meshes and creates edges along the areas. It marks the nav meshes with some kind of area type, area flag. It's not even flag, it's just area type. And it's just a way to filter out some nav mesh polygons, like part of a nav mesh, or like give more cost to certain nav meshes. I don't know what to do about this. I think this is what we would have to do. So we would have to, for all the movements within water, for monsters that can travel in the water, can swim, we would basically use the path that's built along the nav meshes, and we will have to interpolate the z coordinates. So we will strip whatever z coordinates the path will give, as long as each point is within the water volume. And we will just progressively increase, for example, the z coordinate if the end point is higher than the start point. Okay. Well, at least it's not magic anymore. And probably we will still have to use very large extents for the agents. Now, what I wanted to test is if we use these very large extents, would that affect the multi-level zones? So right now we reset this extents. We set this to 1000 meters up and down. So let's restart the server again. Start the client, and let's go somewhere where we have upper and lower floor and see if it snaps. Actually, I need to bring back the normalization of the path. Well, maybe not. No, we can get away without that. Because, yeah, for example, if this is a water volume, then it's possible that the entity, monster or character, for example, would be technically floating above this surface by a pretty long distance. So it can happen that it wouldn't snap. So where are we going? Where do we have multi-levels? Some nice example. Frontera. We have a bridge there. And I actually want the normalization. I need to test this. So let's save, exit. Let's uncomment the normalization. And restart. So, oh my god. Nav mesh. Normalized position. Okay, this looks good. It snapped to my current polygon. The correct one. And here. Okay, so hopefully that wouldn't have any problems. That's good. Where else do we have multi-levels? We have the tower. We have the tower near the arena. Also we have this staircase. Okay, it snapped correctly. Yeah, right now I have basically a kilometer up and down as an extent, so this is actually impressive. This is good. Let's go check out somewhere where we have like 3 levels or even more. So something like this. Okay, this is good. Good. So yeah, it does find the actual nearest polygon. This is awesome. What if I do this? 33. Huh? 17. 6.6, I mean. I think here it actually tries to snap me to the upper position. Let's double check. So it normalizes me to No, wait. Real position. 3853, 3852. Ah, everything's fine. It looks like it pulls me back a little bit. The height level is the same. Okay, we're good. Yeah, this is great. So we can use this. We can even use these extents. Well, not to this extreme amount, not kilometer up and down, but still. This is working perfectly. Now let's try and spawn a monster somewhere, I don't know, here. Follow me. Oops, I actually killed it. Okay, where can we test? Maybe here. I need to make it go above to here. It should be somewhere there. Nice, nice. So yeah, this is working. And I shouldn't be afraid of large extents. This is great. So I guess this is what we're gonna do. So, normalize position. This one's gonna be the same. Well, for now, still I'm gonna uncomment it. No, wait. I don't need it. If I'm gonna try and do this interpolation within water or whatever. So now that interpolation within water, that's gonna be actually a little bit more complex. But okay, we're gonna figure it out. So we have this, let's uncomment extents here. Let's bring back these extents. We need to redefine it basically. So 10 meters to the sides and 100. Oh, I'm thinking in units that are the unreal units. So unreal units, 10 meters is 1000. Okay, that's good enough. 1000 here, 1000 here. Now this is gonna be 10,000. Probably don't need that much. No, actually we do need. So, where is the deepest water? Probably in 𝙽𝙴𝚁𝙀. Unless maybe somewhere incognito or... Let's check out here. I think this is the deepest water ever that we have in the game. So I want to measure the distance, and something along that distance is going to be our extent. So this position minus 16,350, and this minus 26, so 10,000. Even a little bit more than 10,000. So let's do 200. There's gonna be 20,000 in unreal units. Okay. Actually, why am I bothering with these values if they're gonna be defined here? Here, agent half extends. So this is going to be 1000, right? Yeah, 1000 here and there. And here we will have 20,000. Yeah, something like that. And we can tweak it technically for each location, but this is probably gonna be enough. Now another problem that we will have is if we take a look here, for example, where would be the better example? Here. So technically, a monster can swim from like here to there. Wait, I'm using the wrong tool. Test nav mesh. From here to there, but not in these nav meshes. So we have an interruption in a nav mesh here. But because it's under the water, technically it's passable. It's walkable. And here we have a weird thing. Probably I need to take a look into this. I don't think that's normal. Can we do something about that with volumes? Jump? No. How does jump volume, jump area work? Oh, I know. You mark the nav mesh as a jump area, and you connect one polygon with another where you need to jump, and it basically jumps. It's just we can define a cost of a jump. Okay. What is annotation builder? Ground tolerance. Jump link build off mesh links. What is this? Walkable border. Selected and enter. Groundwater road. It's just I wish this build tool would change the like climb, max climb, max slope and max climb within the water to some maximum value. That would fix this bug that we had with monster getting stuck. Because I was basically standing on top of on top of a non-walkable area. So everything that's within the water should be made into a nav mesh. I'm not sure that we can do that. And also that would produce some problems with like hanging edges like this. How do you connect this? Well, at least if we increase slope under the water, this whole portion, top portion, will be made walkable. And that means that from the top perspective, the whole mesh will be walkable. No. I still wouldn't be able to travel from here to there. This is an interesting problem. I'm not sure how to do that. Maybe we can just completely forget about the nav mesh navigation under the water. I don't know. Okay, what is raycast? Can we raycast under the water? Okay, I see. So yeah, it draws a, basically it generates a ray if we don't have any obstacles, but here, for example, it's the same problem. Technically, a ray can be casted, but yeah, it's not aware of the z-coordinate obstacles, how tall they are. It's just a complete interruption in the mesh. It treats it as a wall. Okay. Wait, what? Do we have a path there? Yeah, we do. Okay. But from here to there, there is no way. Okay. This is an interesting problem. Okay. Yeah, basically, probably this is not a good idea to use the nav meshes under the water. We can try and like limit the edges with that. But we would have to build something different, build paths, probably just direct raycasting or direct route if they're within water. I don't know. Because, for example, this is a pretty normal object, right? And this one. So you can swim across it freely with no problem. But if you start here, you end here, it can't build a path right there. Well, the other way around. If you start here, you end there. There is no way you can cross it. It's gonna get stuck here. So let's imagine that these 2 points actually floating above the ground in water. And you build from one point to another. Basically, it's gonna get stuck here. So, I'm not even sure how we can use the pathfinding there. So even if we disregard the z-coordinate, we will have problems like this. And even if we increase the slope angle, this is still gonna be two separate things. Okay, what if we completely ignore nav mesh pathfinding within water and we just build straight path for monsters that can swim? They're probably gonna get stuck in some obstacles, but that's okay. It's better if they're gonna get stuck on the client side and then unstuck after a moment than if they get stuck on the server side permanently. So, but we need to figure out the problems when the interactions when a path goes from water to ground or from ground to into water, or even more complex, from ground across the water to another ground. So what we can do is we can probably check every point of the path. So we will build path. No, still not gonna work. So let's say if we build a path always with nav meshes, so from here to there, for example, or maybe to there, to the ground, and we check every point on the path if it's within water or not. If we are currently in the water and the next point in the water, no, not next point. We need to somehow detect changes in regions, in areas. So maybe something like this. So, okay, we've built a path, right? We are in the water. Then we can check every next next point on the path. If it's always also in the water, then we skip it. If the next one is in the water, we skip it. And until if the final point is also in the water, then we just add the final point. If one of the points is on the ground, then we start using that navigation point and we go to there directly. Otherwise, if the end point is in the water, we go to the end point directly. So this is how we can do this stuff. The problem is, so wait, if we start on the ground, then I check that, yeah, we are not in water, so that doesn't matter. We just, no, wait. We don't even have to check if we are in the water at the moment. So for every point, if it's in water, we just skip it. If it's in water, we skip it. If it's a final point and it's in water, then we just keep it. If the next point is on the ground, we use it. On the ground, we use it. I think this can work. So and yeah, we don't even care if we are in the water. We only care if we can swim. So if we can swim, we can skip any navigation point that's in the water. But there is a problem. It's still things like this. When both of the points are within the water, but they have an obstacle in front of them. And they cannot be reached with the nav mesh. So if it's a normal obstacle, and you can actually find the path, and all the points of the path is within water, it will just go directly. But if some of the points that go around are on the ground, then it will actually go to the ground and then back into the water. But if it's completely unreachable, even though both of the points are in the water and everything is good, then we have a broken path again. That's the biggest problem. Otherwise, we can solve this, no problem. And if we completely ignore pathfinding within water, so let's say that both points are within the same water volume, right? then we just create a direct path from one to another. Let me think. So if we do that, then any obstacles on the way would be ignored. So basically, pathfinding in the water would not work at all. The monsters will go directly, which is okay. At least it's better than to get stuck. But what if one of the points is on the ground? What if the monster cannot cannot walk on ground, can only swim? Or the other way around, if the monster cannot swim, can only walk on the ground. Well, that means that we can just build normal pathfinding. What if we have a water between two ground surfaces, and we need to build a path from one to another with the water in between? I don't think we actually have something like that in the game, but just theoretically, then what would happen? We would still try to build a path. If there are some unwalkable obstacles in the water, that will be just broken. The path would fail to build. But actually, no, it's still gonna fail. The same problem is if we have obstacles in the water and the final point is on the ground. The other way around. So, we are in the water here. This is the example actually. We are in the water and the final point is on the ground. And we have an unreachable obstacle. The path would not be built. But you know what? Maybe we can do the other way around. So if we detect that we cannot build a path, the monster gets stuck and it's in the water, we can then try and build the path the other way around. So from the ground back to the water, and we will have a longer path, right? And as soon as it reaches water, that's gonna be our next waypoint. That can work. But at least for now, we need to exclude the navmesh navigation when you're in the water, or at least both points are in the water. No, wait. Yeah, we build the path. No, wait. I need to write all of that down. I'm saying a lot of different ideas, but I keep forgetting them immediately. So, let's say if both points are in the same water volume, right? So we define this restriction. So if they are in the same water volume, direct path. We don't use pathfinding at all. If one point in water, other on ground, then we build path from water. No, start in water, start point in water, finish on ground. Build path from water to ground. Skip any points that are in water. That's it. But if path building failed, that means that we have some kind of obstacle either on the ground or in water, and it's unreachable. No, wait. Path building will not fail, actually. It will not fail. That's an actual problem. It will try to go to the nearest point, and that's it. Okay, then this is not a failed path. Build from water to ground. Skip any points that are in water. So it's in this case, for example, so we will pick the first point that's on the ground, and we will travel directly there, and then we will travel on the ground. Okay, if path is incomplete, path is incomplete, and the final point is in water, so we could not get out of water. So it's this, in this example, for example. So it's this example. We are still in water, but we cannot reach the final point. Then we need to try and build the path in reverse. And get the first point that's in water. Wait, how do I describe this? Build path in reverse. Build the reverse path, right? Check if final point, final reverse point is in the same water volume. if so, then we process it in reverse as if we would basically skip all the other points. Something like that. That would make sure, so if we process the path in reverse, that would look like this, and the final point will be in the water. So we treat it like a normal path, we go backwards, we check, it's in water, we skip, water, skip, until we reach the point on the ground, and then hopefully we can proceed from there. And we go directly to that first point on the ground. So this is how we can try and fix this. The problem is this thing now has to be aware of a lot of different geometric data, like geodata. So it has to be aware of navmesh and be aware of the physics volumes, and has to be the same piece of code basically. Okay. So start point and water, finish and ground. Next case. Start point on ground, finish in water. So yeah, build path. Build path normally. And skip any points that are in water. This still holds. So we will go on the ground, and as soon as we get into the water, we go directly to the final destination. Skip any points that in the water, except the final destination. Actually, it should be there, because this will always skip the water point. So skip any points that are in water except the final destination. So we travel through the ground normally, then as soon as we get into the water, we skip anything. So again, if path is incomplete and the final... Wait. Oh, yeah. If path is incomplete and the final point is... I see. Skip any points that are in water. Okay, if path is incomplete and the final point is in water, at the final destination, at the final point. Now, if path is incomplete and the final point is on ground, then we stay on the ground. So this one's easier, right? So for example, yeah, we start here, we end here. We build the path. We don't need to build it in reverse. As soon as we get into the water, we skip everything else and go there directly. Now, another case. Another case is if we have a body of water between 2 points on the ground. So start point on ground, end point on ground. Skip any water, any path, any points that are in water. And that would actually take care of situations where we have an obstacle that cannot be bypassed in the water. So if we build a path from ground to ground, we have a water in between, and we have an obstacle in between, in the water. The path will be like built up until the obstacle, right? So then up until the obstacle, and the monster will travel there, and it will actually then stop and try to build another path. And that will be case when the start point is in the water, finishes on the ground, and it will basically avoid the obstacle that way. But what if we have an actual obstacle that shouldn't be passable at all, like walkable, swimmable, whatever? Then we would have to separate them and have them in a different water volumes, in different water volumes. So let's say we have some kind of cage in the water. Crap, this is becoming much more complex. Let's say we have some kind of cage or cave in the water. That has no entrance. The monsters are, for example, swimming within that cave or cage, whatever. We would have to basically place, like enclose all that cage with a separate water volume. That would mean that you cannot go from one water volume to another. Also skipping same water volume. Okay, I'm gonna check all of that. So when we are skipping, we also need to check if the water volume changes. So let's do it like that. So when we are skipping any points that are in the water, we also check if we enter a different water volume. So the first point that we detected that is in the water, we memorize the volume ID, and we check the next point. If it's in the same volume, we skip it. If it's the same volume, we skip it. If it's in the different volume, we now replace the ID that we memorized with the new ID, and we keep the point, and we go next and next and next. Okay. Now, when both points are in different water volumes, then what do we do? It's not going to be a direct path anymore. We would have to build the path. So build path from one point to another. And then we normally like skip any points that are in water in the same water volume. Right? And yeah, here it's gonna be actually possible that there is an obstacle that you cannot overcome. The monster will be basically blocked. So it's gonna be either at the end of the water volume or no, wait. Let's say we have an obstacle in the first water volume, but we can ignore it as long as the rest of the path is fine. So we're gonna build in reverse. So if path is incomplete, we need to use this one. So if path is incomplete and the final point, if the path is incomplete, we try to build it in reverse. We know that the final point is in a different water volume. We build the path in reverse. If the final reverse point is in the same water volume. If so, yeah, then we connect basically the two paths. So this is probably our solution. I think it covers everything except, yeah, the monsters will get stuck in water on the client side because on the server they will be traveling straight through any obstacles like they do right now. But still it's better, I think, than any other solutions. Another problem is we should probably align them to the ground when possible. So for example, if a line goes through the terrain, we should try to raise the z coordinate to the terrain height. But that's like a minor change. Now, if the monster, right now we're considering monsters that can swim and walk. Well, this thing also works for just swimming monsters. It's a direct path. So if they can swim and walk, this is what's gonna happen. If they can only swim, but still this is gonna be working. It's just their final path is going to be somewhere on the edge of the water. And this is gonna be a direct path. Right? Yeah. So if for monsters that can only swim, one point is in water, second point is in the same water volume, then it's direct path. It's the same as this. If their final point is on the ground, the path will be just built up to the ground. And yeah, they will just travel directly there. We will skip any points that are in water, and we will keep the final destination. But we will not probably build the path from the ground because, yeah, we cannot do that. Well, in this case, maybe we need to not only build the path from the ground in reverse, but we should actually change the movement flags so they include all the flags. So we can actually build the path and connect them together. I don't know. This is an edge case. And for the monsters that cannot swim, this is basically very simple. This is normal. They will just follow the ground directly. So this is easy. Okay. So I think this is the way to go. Now we need to implement that. And yeah, I am not sure how to do this because here in this navmesh geodata provider, we don't consider physics volumes at all. So probably we would have to combine navmeshes and physics volumes in one geodata provider that can build the path. Because I don't think we can do this in a more intelligent way. Well, maybe we can do it on a higher level. So here, for example, like we do this fix. We can do that for build path. So we try to build path normally. I don't know. That's gonna be hard to come up with. Probably I should forget about this abstraction, these collections, and basically build everything into one geodata provider and then see if we can somehow refactor that and optimize this logic. But okay, this is gonna be the way to go. And I think I'm going to call it a day. It's been a long day, a lot of experiments. And yeah, we actually did something, we finished something at least. We implemented the import of the Ragnarok Online 2 volumes, physics volumes, into here. And that actually works, surprisingly. But we still need to create an offset for the water volumes, I think. Well, I will think about that. That's gonna be next time, I guess. Can we find someone to raid? But yeah, I was expecting a little bit more from this library. But yeah, probably this is the way to go. It's just weird. The same is gonna be with the flying physics, although we don't have flying monsters, but yeah, if we would implement flying monsters, it would be absolutely the same problem. We have obstacles, but we can't use nav meshes for these obstacles. I don't know. This is going to be a hard thing to solve. So, yeah, I'm gonna call it a day. I will continue maybe tomorrow, but probably on Tuesday, most likely. So I will have a little bit more time to think about this and do some other chores. So yeah, today was a weird day. At least we did something and did a lot of experiments, and we found out that we cannot just blindly rely on this library. So yeah, we will figure it out eventually. We'll see. Hopefully until the next stream I will have some plan. We'll see what we're gonna do. So yeah, thank you everyone for watching. I really hope to see you on the next stream. Bye bye.